You delete a pod, Kubernetes deletes it immediately, simple. Now you delete a persistent volume, Kubernetes waits, why? Finalizers. A finalizer is a key stored in an object's metadata.finalizers list. It tells Kubernetes, before you delete this object, something must happen first. When you issue a delete, Kubernetes does not remove the object right away. Instead, it sets a deletion timestamp on the object, a soft delete signal. The object is now terminating, it still exists. Controllers watching it see the timestamp and act. Each controller removes its own finalizer once its cleanup work is done. Only when the finalizers list is completely empty does Kubernetes actually delete the object. This creates a two-phase deletion process. Phase 1, the deletion request arrives. Kubernetes stamps the object with a deletion timestamp. The object enters the terminating state. It is still in ect. It still shows in kubectl get. Phase 2, controllers perform their cleanup, detaching volumes, releasing IPs, draining queues. Each controller patches the object to remove its finalizer key from the list. When the last finalizer is removed, Phase 2 ends. Kubernetes purges the object from ect. A finalizer can prevent deletion indefinitely. If a controller crashes or bugs out, its finalizer is never removed. The object stays stuck in terminating forever. To unblock it manually, kubectl patch the object and remove the finalizer from the list. But be careful, removing a finalizer manually skips the cleanup that finalizer was meant to do. The most common built-in finalizer is Kubernetes.io/PV protection. It lives on persistent volumes that are actively bound to a PVC. It prevents a volume from being deleted while a pod is still using it. Another one, Kubernetes.io/PVC protection, protects persistent volume claims in use. Operators and custom controllers define their own finalizers. Any valid label string works as a finalizer key, for example, finalizers.example.com/cleanup. Now let's talk about owner references. In Kubernetes, objects can have parents. A replica set owns its pods. A deployment owns its replica sets. This relationship is encoded in the owner references field of each child object. An owner reference contains the parent's API version, kind, name, and UID. The UID is critical. It prevents a new object with the same name from being mistaken as an owner. An object can have multiple owners, but they must all live in the same namespace. Cross-namespace ownership is not allowed. Owner references power cascading delete. When you delete a deployment, Kubernetes marks it for deletion. The garbage collector sees that the deployment's replica sets have an owner reference pointing to it. Since the owner is gone, the garbage collector deletes the replica sets, which in turn triggers deletion of the pods those replica sets owned. The whole tree collapses automatically, no manual cleanup required. This automatic cleanup is handled by the garbage collector controller in the control plane. It watches for objects whose owners no longer exist. These are called orphaned objects. They have an owner reference, but the owner is gone. The garbage collector deletes them. Delete a replica set directly and watch its pods disappear moments later. Sometimes you don't want cascading delete. You want to keep the children. Use the orphan deletion policy, kubectl delete with cascade equals orphan. This deletes the parent but leaves the children alive. Their owner references now point to a non-existent object. Use orphan policy when migrating ownership or preserving running pods during a rollout. Finalizers and owner references are Kubernetes twin mechanisms for safe, ordered cleanup. Finalizers gate deletion until work is done. Owner references wire the object graph. Together, they let controllers clean up complex state without race conditions. Run the docs, Kubernetes, finalizers, and owners.